Next we come to the idea of a polar curve, and it's really pretty straightforward. It's a set of all points that satisfy an equation in r and theta. And polar curves can be very, very simple. Like, you could have the equation r equals 3. Okay. The graph of that curve would be all the points that have a distance from the origin of 3 units, since r is the directed distance from the origin. That describes a circle, basically. Actually, we can generalize that. And if you have r is equal to some constant a, that is going to be a circle with a center at 0, 0, and radius equal to the absolute value of a, because that a could be a negative number. The angle theta equals pi over 3. Okay, that's the set of all the points that are pi. Well, it's the set of all points whose angle is pi over 3 from the positive x-axis. So that's a line. Okay, it's a line that goes through the origin. And the angle with the x-axis, so with the positive x-axis, is pi over 3. Alright, so to generalize that, if you've got theta is equal to some specific value, we'll call it theta sub 0. It's the line through the origin whose angle is theta sub 0 with the positive x-axis. So let's see if I can do this. Of course I can't. Make this, oops, I didn't want to do that. So when we had theta is equal to pi over 3, that was the last example we were talking about. So the generalized version, theta equals theta, it is going to be the line through the origin whose angle is theta sub 0. Alright, one more very simple one before we start looking at something a little more interesting. If you have r is equal to theta, okay, now as long as theta is we're going to say theta is greater than 0. So we're talking about positive angles. Think about what happens as theta increases, so does r. So your graph is going to will result in making a spiral that'll start at the origin. And as theta, as the angle gets bigger, so is the distance from the origin. So it's going to be a spiral that sort of is drawn or constructed counterclockwise. If you were using negative angles for theta, then you'd have a clockwise spiral. All right. So it's more often that you're going to see polar equations that we would need to get polar curves graphed for, where you've got r and theta in the same equation and there's something else in there, like 4 times sine of theta. The way that you sketch a polar curve is by plugging in different values of theta. What angles make sense? Well, the special angles, since those are the angles that we know sine and cosine values for, those are the ones that make sense. So if I start with theta equals 0, then I'm thinking r is going to be 4 times the sine of 0, which will be 0. So that point is the point 0, 0. And then if theta is pi over 6, then the value of r would be 4 times the sine of pi over 6. So we're looking at 4 times a half, or 2. So 2 pi over 6 would be the next point we plot. So pi over 6 is here, and then we're going to count out 2 units out that line. And then move on to pi over 3, pi over 4 is the next special angle. So r is 4 times the sine of pi over 4. So 4 times the square root of 2 over 2. So we get 2 square roots of 2, comma, pi over 4. And we grab our trusty calculator to get a decimal approximation for 2 times the square root of 2, and that's 2.8. So I think about the angle, the angle pi over 4, and I'm going to count out not quite 3 units out that ray. And then moving on, theta is pi over 3. R is 4 times the sine of pi over 3. So 4 times the square root of 3 over 2, which would give me 2 square roots of 3, comma, pi over 3 for my point. So 2 square roots of 3 is 3.5 roughly. So I think about the angle pi over 3 radians, and then I move out that line about 3.5 units. 1, 2, 3.5. Alright, so next angle, pi over 2. R is 4 times the sine of pi over 2, which is going to give us a value of r that's 4, so we have the point 4 pi over 2. 2, 3, 4, so that'd be that point about right there. And then theta is 2 pi over 3 is our next special angle. R is 4 times the sine of 2 pi over 3. And you certainly don't have to write all this down. I just want to be very, very clear about where I'm getting my points. Wow, leaky pen. 4 times square root of 3 over 2. That's going to be 2 square roots of 3, 2 pi over 3. So I think about 2 pi over 3, and then I'm going to go out that 1, 2, 3.5, about 3.5 units. And then we move on to the next special angle. Theta is 3 pi over 4. Sine of 3 pi over 4 is going to be square root of 2 over 2. So we're going to end up with the ordered pair 2 square roots of 2, 3 pi over 4. So I focus on the ray where 3 pi over 4 is, and then I count out not quite 3 units out that line. About right there. So the next angle, theta is 5 pi over 6, and r is 4 times the sine of that angle would be 1/2, so that's going to be the ordered pair 2, 5 pi over 6. So let's see, 5 pi over 6 would be this ray, and so our point would be, point would be there. Okay, next angle is pi. R is 4 times the sine of pi, so that's 0 pi. And that ends up being in exactly the same place that we had our, the point 0, 0 is. So we've got a repeat, and that happens. 7 pi over 6. Value of r would be 4 times negative 1/2, which gives us negative 2, 7 pi over 6. So if I plot that point, 7 pi over 6 is here. Count in the opposite direction, so directly across the circle, 2 units. So we've already got a point there, and that's okay. And actually what we're going to see happen, you can keep going, but you're going to find that you end up covering these same points again. So in this particular example, to get the entire graph, or everything that the graph of r equal 4 sine theta is going to do, we only needed to look at an interval of angles from 0 to pi. The others are all repeats. We do exactly the same thing again. So this polar curve would be the curve that goes through those points, which appears to be a circle. Specifically, it appears to be the circle with a center right there. So if I'm thinking about the x-axis and the y-axis here, looks to me like the center of that circle is at the point 0, 2, and the radius is 2. Now, how can we, check that out? Well, one way to do it is to convert that polar equation to a Cartesian equation. So again, we've got r and theta, and we want to find x and y. Things that we know are that r squared is the same thing as x squared plus y squared. The tangent of the angle theta is y over x. R times the cosine of theta is equal to x, and r times the sine of theta is equal to y. These are all kind of the conversion factors, for lack of something better to call them, between Cartesian and polar. So if I'm looking at this equation, I kind of notice that if I multiplied by both sides of the equation by r, I would have r squared equals 4 times r sine theta. And r squared is x squared plus y squared, so I could make that switch. And r sine theta is y. So now I have changed that into a Cartesian equation. Now, that doesn't look like the equation of a circle, but with a little bit of work, and completing the square would give me the equation x squared plus the quantity y minus 2 squared equals 4, which is the equation of a circle with a center at 0, 2 and a radius of 2. Okay. Kind of in general, equations that you should be able